Hello everyone, my name is Abdalmalek AlSebaee, and me and my friends are going to present how keyboard works. Keyboards are something we all use daily with our computers, but we might not think about how they work. This presentation will show how keyboards work, the different types, and their history. So let's get started. Introduction. Keyboards are one of the most important tools for using computers. They let us type words, numbers, and commands into the computer. Over time, keyboards have changed a lot to become faster, more comfortable, and easier to use. Today, we will explain their basic functions, the different types, and how they have evolved. When you press a key on the keyboard, it sends a signal to the computer. Each key has a unique code called a key code. The computer receives this key code, and understands which letter or number or command you pressed. For example, pressing the letter A. Key sends the code for A, and the computer shows it on the screen. This happens very quickly, so typings feel smooth and instant. Now let's talk about mechanical switches. These are the most adorable type of keyboard switches. They give what we call tactical feedback. This means you feel a small pump or resistance when you press a key. Each key has its own switch made of materials like metal, plastic, or rubber. When you press a mechanical key, you might hear a click sound and the key feels solid. Mechanical keyboards are very popular because they last longer and feel satisfying to type on. Now we understand what the mechanical switches are. So we're going to explain types of mechanical switches. So the first one we're going to talk about is cherry mix switches. They are the most common. They come in three styles: tactical, linear, and clicky. Tactical switches give a pump when you press them. Linear switches are smooth and quiet. Clicky switches make a loud clicking sound. The second one is Woomer G switches. These are faster and quieter. They are often used in Logitech keyboards. The third one is Balking Spring. These switches are known for their loud clicks and unique feel. They were used in older keyboards but are still loved by some people. The fourth and the last one is optical switches. They are the newest type. They use light sensor instead of physical parts, so they are faster and last longer.
On the other end of the spectrum are membrane keyboards. These are typically quieter and more affordable compared to mechanical keyboards. Instead of individual switches, membrane keyboards use a flexible membrane layer beneath the keys. When you press a key, the membrane pushes down, completing a circuit, and the computer registers the input. While these keyboards don't provide the same tactile feedback as mechanical ones, they are still widely used because they're cost-effective and work well for casual typing and office tasks. The only drawback, however, is that they don't have the same level of responsiveness or the durability as mechanical keyboards. Now that we understand how the keyboard registers a key press, we will talk about how the key press is turned into a character the computer understands. In the following slide, key encoding ASCII versus Unicode. Now this process relies on encoding systems such as ASCII and Unicode. ASCII, which stands for American Standard Code for Information Interchange, is a system that encodes 128 characters, including letters, numbers, punctuation, and also control characters. It's widely used for English text and simple commands, but as our world becomes more global, we need something that could handle more languages and symbols. Enter Unicode, which supports over 100,000 characters from virtually every language and includes emojis and other symbols. Unicode is really, in the end of the day, the more modern and versatile encoding system, and it also allows computers to work with a much more wider range of characters, as well as symbols. So after you press a key, How does the signal actually get to your computer? It depends on the type of connection your keyboard uses. PS2 is an older connection standard that's mostly been phased out. USB is the connection most commonly used today in wired keyboards, and it's great because it's fast, reliable, and easy to plug in. For wireless keyboards, however, Bluetooth has become the standard, allowing you to connect your keyboard to a computer or device without needing any cables. The wireless setup is especially convenient for reducing desk clutter, but the thing is the keyboard will require batteries or charging. Regardless of the connection, though, the signal travels from the keyboard to your computer in a way that ensures it's registered quickly and accurately.
The keyboard matrix is the underlying grid of circuit that detect key presses. It is arranged in rows and columns, with each key positioned at the intersection of a row and a column. When a key is pressed, it completes a circuit that intersection a signal to the keyboard controller, which key has been activated. The design simplifies wiring, reduces cost, and enables compact layouts while maintaining functionality. Key rollover refers to keyboard ability to recognize and register multiple key presses. There are two main types. Two-key rollover, the keyboard can detect up to two keys presses at the same time. Additional key presses may be ignored. N-key rollover, this allows the keyboard to detect and register unlimited number of key presses at once, essential for gaming and high-speed typing. Key rollover ensure accurate input during complex or rapid typing and gaming session. On the next slide, we have anti-ghosting technology. Ghosting occurs when pressing multiple keys, resulting in keyboard registering additional unintended key presses. To prevent this, modern keyboard implement anti-ghosting measuring, including enhanced circuit design. Each key circuit is isolated using DDoS or similar component to prevent signal conflict. Optimized firmware. The keyboard software filter out phantom signals to maintain accuracy. Specialized matrix layout. Keyboards, particularly those designed for gaming, often prioritize areas like WASD zone to handle multiple simultaneous input without errors. This solution ensures reliable performance, especially in scenarios requiring fast or complex key combination.
A wireless keyboard is an input device that allows the user to communicate with computers, tablets, or laptops without the need for physical cables by utilizing radio frequency signals or a Bluetooth connection. These types of wireless keyboards are becoming more and more popular and widespread because of their convenience and portability. RF keyboards specifically connect to your devices using USB sticks. This way provides a more stable connection than a regular Bluetooth one. And now we move on to ergonomics in keyboard design. Ergonomic keyboards are keyboards that are designed to provide the most comfort possible to the user with the aim of minimizing strains in users' fingers and wrists. These keyboards may contain features such as a split layout, adjustable height, and even angled keys so that it reduces the effort that you, the user, needs to put in using them. These keyboards are not made just so that they look cool or futuristic. They aim to prevent repetitive strain injuries like carpal tunnel syndrome, which is caused by pressure on a nerve in your wrist. It causes tingling, numbness, and pain in your hands and fingers. This is one of the major reasons ergonomic keyboards exist. And now we move on to the future. The future of keyboards looks to be not only promising, but also exciting. Laser projector keyboards remove the physical aspect, the need to carry around a keyboard with you wherever you go. They work by projecting an image of the keyboard into any table or flat surface you may have, and when you touch or press these keys, a sensor logs your keystrokes and inputs them into the computer directly. Who knows what else the future may hold for keyboards, or computers for that matter. We are reaching the end of our presentation, and we want to close with a few final remarks. The keyboard is one of the most important tools that we use in everyday life, and it keeps on evolving and improving, becoming more fit for our needs and safer for us to use. I think it's safe to say that the future of these helpful devices looks bright and promising. This presentation was prepared by these lovely gentlemen, Abdalmalek AlSebaee, Hisham AlBaiti, Mohammed AlZubaidi, and I, Abdullmohsen AlGhamdi. We would love to take this moment to thank the wonderful Dr. Tawfiq Hasneen for bringing us together and allowing us to make this hopefully educational presentation for you. And we would also like to thank you for listening. We hope you learned and enjoyed. And with that, we've officially reached the end. Goodbye and Assalamu alaikum wa rahmatullahi wa barakatuh.